Good morning, Geometry Honor students. So this is Mr. Chen again. So today I would like to talk about, well, this one is to consider Chapter 7. I know this one is showing that Chapter 5 is Chapter 7 from the Big Idea textbook. So this one is another, textbook that I use to generate all the material. So it's about the rhombi or the rhombus and squares. Okay, so let's take a look at that. So the warm-up problem, just like what we talked about last time for the special parallelogram, rectangle is one of the special parallelogram, and the other two special parallelogram, then that will be considered rhombus and square. So definition of a rhombus. A rhombus, it's a parallelogram with two congruent consecutive sides. So two congruent consecutive sides. Okay, so for the rhombus, so here's the properties of a rhombus. A rhombus has all the properties of a parallelogram. A rhombus is equilateral, so all four sides are congruent. And the diagonals of a rhombus are perpendicular to each other. So let's say that you want to draw the diagonal from one vertex to another vertex. So they're actually perpendicular to each other. Okay, so perpendicular, 90-degree angle. And the diagonals of a rhombus bisect its angle. Okay, so the angle right here, so they're all being bisect. Okay, so all those angles there, they're all being bisect. And what about a square? A square, it's a rectangle with two congruent consecutive sides. So again, all four sides are equal, if that's a perfect square. So a square has all the properties of a rectangle. A square has all the properties of a rhombus. That's true. So this one is perpendicular, 90-degree angle, 90-degree angle. And also the diagonal. So they're always perpendicular to each other. And obviously the angle, they're always bisecting. So 90-degree, half of it, 45-degree. So now let's take a look at that, some of the problem. So problem involving the squares. If segment AB is 2x plus 4, so segment AB is 2x plus 4. So CD is 3x minus 5. Find the measure of segment BC and segment BD. Well, this one is actually pretty straightforward. So just basically find out the value of x first. So since we do know that this one, it's a square, so we can set that 2x plus 4 equals 3x minus 5. So solve for x, subtract 2x on both sides, add 5 on both sides. So what we found here is we got 9 equals x. And then just plug in a number back to one of the binomial expressions. So let's say that, find out AB first. So 2 times 9 plus 4. So 2 times 9, that's 18. 18 plus 4, which is 22. Okay, let's see right here. So we do know that it's a square, so each side got to be equal, so 22. So that means for BC and BD, you got to be 22 as well. So those two segments, BD, then that'll be the diagonal. So let's find out the diagonal. So the way to get the diagonal is just using the Pythagorean theorem. Okay, so 22 quantity square plus 22 quantity square, and then square root of the whole quantity. So 22 square, which is 484. Okay, so 22 times 22. So 484. So 484 plus 484, or 484 times 2. So we'll get, well, this one you just want to simplify it a little bit. So before we multiplied it, so this one we take the square root. So perfect square number. So it's going to be written as 22 root 2. Oh, the other way around. So 22 root 2. Another way you can do it is by using the special right triangle, which we'll get to that to one of the unit using the trigonometry relationship of the special right triangle. So here's another one. So if the measure of angle AEB is 3x, so AEB right here. So if this angle is 3x, find the value of x. Well, this one is actually pretty basic. So 3x equals 90 degrees. If that's a square, so that means it pretty much has all the properties of a special parallelogram, the rectangle, and the rhombus. So rhombus, so that means all the diagonals, once they intersect, so it forms 90 degrees, they're perpendicular. So we said that 3x equals 90. So x equals 30 degrees, 30. So solve for x, so just say that x is 30. So find the measure of angle BAC. So BAC, which is what, 90 degrees, find x. So let's see, BAC right here. So BAC, this angle. Again, if that's a square, so the measure of the entire angle is 90. So the diagonal, it just bisects the angle. So 90 divided by 2. So 90 divided by 2, then that'll be 45. So 45 degrees. So 45 equals 9x. So angle BAC divided by 9. So we got x equals 5. So the perimeter of the square is 32. Find the length of diagonal DB. So that's 32. So 32 divided by 4, because that's 4 sides, if that's a square. So which is 8. So we got 8, 8, 8, and 8. So in order to find the measure of that, the diagonal DB, so using the Pythagorean theorem, a squared plus a squared, and then square root of the whole quantity. So square root of 64 times 2, and then we do have 8 root 2 centimeters. So problems involving the rhombus. So dm, okay, so this one is given. ml, okay, so the other side length it's given. So we do know that's a rhombus, so that means all 4 sides are equal. So 6y plus 4 equals 5y plus 8. Solve for y first, subtract 5y both sides, so we got y equals a minus 4, so y equals 4. And then the one that you want to solve for is KL. So KL, pretty much the same as ML or DM. So plug in a number, so we got 5 times 4 plus 8. So 5 times 4, that's 20, plus 8, 28. And if the measure of angle D is 7x minus 28, the measure of angle K is 10x minus 13. So measure of angle D and the measure of angle K so find the angle in a rhombus. Okay, so again, if that's a rhombus, so that means the opposite angle got to be congruent. Okay, and also this one has all the special properties of the parallelogram, so that means the consecutive angle got to be 180 degrees. So 7x minus 28 plus the quantity of 10x minus 13, so that equals 180. So 7x plus 10x, so we got 17x. Negative 28 minus 13, so for that one we do have negative 41, so that equals 180. So add 41 on both sides, so we got 17x equals 221. And then divided by 17. Okay, so you want to find out what x first. So 221 divided by 17. 13. So after you solve for x, so you want to find out the measure of the angle, so plug in 13 back to the original expression. So 7 times 13 minus 28, and then 10 times 13 minus 13. Okay, so just find out the measure of the angle by plugging a number back to the original expression. Okay, so now the next one, find the measure of the number angle in each rhombus. Okay, so the measure of angle 1. So one thing that we notice, this one is 58, so that means the other angle here, it's also what, 58. And one thing that we notice, the diagonals of the rhombus, they always bisect, they always perpendicular to each other. So this one is 90 degrees. So to get the measure of angle 4, so using that, the triangle sum theorem, 180 minus 90 minus 58. In other words, 90 minus 58. So then that'll be 32 degrees. So angle 3, 32 degrees. And the other thing that we notice, if this one is 32 degrees, angle 1 is also 32 degrees. Because those two diagonals, they always bisect the angle. And then measure of angle 2, obviously it's 90 degrees, perpendicular. Angle 4, well, excuse me, angle 4 is supposed to be 32 degrees. I put it for angle 3, so angle 4 is supposed to be 32 degrees. So this one's 32, this one is 90, and then find out the measure of angle 3 right here. So this one is also considered 58 degrees. Again, the opposite angle, they're always congruent to each other. Okay? And also the diagonal, it bisects the angle. Okay, so now let's see what else that we have for this. The diagonals of a rhombus are 10 and 24. Okay, so draw the rhombus. So diagonal. So one is 10 and the other one is 24. So in order to create that, the length of the sides of the rhombus, all four sides are equal. So basically we just like taking out one of the triangle here. So half of 24, which is 12, half of 10, that's 5. So using the Pythagorean theorem, we'll get this one, it's 13. Okay, so plug in a number, 5 square plus 12 square, 25 plus 144, so it's 169, so square root of 169, which is what, 13. So the side length for the rhombus is 13. Okay, so now let's take a look at that. What else that we have for the rest of this here? Proof. Alright. So given that rhombus, ABCD, FEC, AED, okay, so those, the plane, and also the segments, and then angle FAB is congruent, okay, FAB. Okay, so this angle here is congruent to angle DCB. Okay, it looks like this one is kind of perpendicular, but anyway, just put it this one first. So you want to prove that segment FE is congruent to segment DE. Okay, so we want to show that these two segments here, they're congruent to each other. Okay, so rhombus ABCE. Okay, so ABCE, this one is a rhombus. So if this one is a rhombus, so that means all four sides here got to be congruent. Okay, so start with the given statement. Given ABCE, it's a rhombus. So if that's a rhombus, so that means we do have segment EC is congruent to segments AE. So this one is just by using the definition of a rhombus or the properties of a rhombus. Property of a rhombus, that would be more appropriate. Property of a rhombus. Okay, so now let's see what else that we need to do right here. So in order to prove that this one, they're considered congruent, so we need to prove this two triangles got to be congruent first. Okay, so another thing that we can state And one thing that we notice, angle FAB, this angle here, is congruent to angle DCB, okay? Okay, so before we do that, another thing that you want to stay here, angle EAB is congruent to angle ECB. And also the property of a rhombus. Opposite angles, they're always congruent. So now by using the angle subtraction postulate, so that means angle FAB minus angle EAB. So that will give you the measure of angle FAE. And also at the same time, right here, the measure of angle DCB minus the measure of angle ECB. So that will give you the measure of angle DCE. So for both this one you can just say that it's angle subtraction postulate. And therefore, angle FAE is congruent to angle DCE. So this one is by using definition of congruent angles. Okay, by the definition of congruent angles. And now let's see what else. So we're saying that this angle here, they're congruent to each other. So basically what we found here, we got psi angle. So it looks like we need to prove another angles which they're congruent as well. Okay, so here's another thing. We can use that the angle Psi Theorem. Since we do know that these two sides are congruent, so that means the corresponding angle got to be congruent here as well. Okay, the corresponding angle. Okay, so we can say that angle F is congruent to angle D. This one's by using psi, the converse of angle Psi theorem. And the reason why that is because that these two sides are congruent, so that means the opposite angle, they got to be congruent as well. So using that angle psi, so we can say that triangle AFE is congruent to triangles CDE by using angle, let's see right here, angle psi theorem. Okay. So now, what about for the next step here? So once we prove those two triangles are congruent, so we can state that segment FE is congruent to segment DE by using CPCTC, just like that. So it's very important to prove that the congruent triangle first. So once we prove those congruent triangles, so basically we can state that the corresponding part of the segments or the angles got to be congruent. Okay, so making sure that, so we have to prove that the congruent triangle first. So here's another proof. Okay, so now let's take a look at that. So rhombus ABCD, and this time we want to prove that ABCD it's a square. So one thing that we notice, BL is congruent to CM, so BL is congruent to CM. BL is over there, right here, congruent to CM. And what else do we know? AL is congruent to BM. So AL is congruent to BM, like that. Okay, so one thing that we need to show here, so ABCD is a square. In order to prove that ABCD is a square, not only we have to prove those four sides are congruent, but also we need to prove that the corresponding angle got to be congruent as well. Okay? And also we need to prove that they consider 90-degree angle. So if that's a rhombus, so ABCD is a rhombus. So basically this one tells you that all those four sides got to be congruent already. Okay, so given statement. So this one can just say that segment AD is congruent to segment AB, and it's congruent to segment CB, and it's congruent to segment DC. Okay, so once we do that, and other things that we need to prove here is that the angle. Okay, so we just want to show that these two angles, they're congruent to each other. Okay, so this one is by using properties of a rhombus. So now, in order to prove these two angles are congruent, so we want to show that these two triangles here, they're congruent as well. Okay? So another thing that we can say, so BL is congruent to CM, AL is congruent to BM, given okay, so if those two sides, two pairs of sides are congruent, and also that BC is congruent to AB, so therefore triangle ABL is congruent to triangle BMC. Okay, so this one's by using psi. And then, therefore, we can say that angle C is congruent to angle B right here. Okay, so angle C is congruent to angle B. So this one just state that it's considered CPCTC. Corresponding part of congruent triangles are congruent. And also we can say that the opposite angle, angle A, is congruent to angle C. And also angle B is congruent to angle D. And the reason for that, this one is by using the property, so for rhombus. Because at the opposite angle, they're always congruent. So using all those information, we can say that angle A is congruent to angle D, and angle C is congruent to angle B. This one is just by using transitive property. Of equality. So once we prove that all those four angles are congruent, the four sides are congruent, and other things that you want to stay here, angle A plus angle B plus angle C plus angle D equals 360 degrees. So this one is by the sum of all the interior angles of a quadrilateral. And then finally, you want to say that angle A equals angle B equals angle C equals angle D equals 90 degrees. Okay, so this one, it will be divided by 4. So division properties of equality. And then finally, number 11, ABCD, it's a square. Definition of a square. So again, anytime that you want to show that the quadrilateral is a square, so not only you need to put in those properties of a rhombus, so showing that all 4 sides are congruent, all angles, not just the opposite angles are congruent, all 4 angles got to be congruent as well. And also showing that the sum of all the measure of the interior angle got to be 360 degrees. And then divided by 4, then you'll get 90 for each angle. Okay, so now the rest of this is more challenging problems. Okay, so make sure that you guys read through this one. So follow through the instruction using the properties of a square, rhombus, and then viewing this chart. And also, there's some other problem that you guys can work on. So the practice problem, okay, giving that the diagram, and then you want to find out the missing angle or the missing segment. So it's quite similar to the one that we did earlier for the practice. Okay, so to look at that, so this one is just a practice problem from this sections, and also more proof, quite similar to the one that we did. Alright, again, you want to prove that ABCD is a square. So thank you for watching the video today. So guys, do you have any questions? So please send me, just leave the comments there on the YouTube video clip there for the comment bar, and then I'll see you next time.